Now it's time for Mr. Henri Vincent-Henri Peuch from the Weather Center in Reading, ECMWF, very advanced abbreviation, European Center for Medium and
Range weather forecasts.
Yes, very complex, but it's a complex matter. I understand that you are in charge of the MAC project and dealing with research on atmospheric issues earlier at France, but now responsible for the atmospheric monitoring service at the Weather Center. Please.
Thank you very much.
Just your mic a bit.
Yeah, thank you very much. Hello from my side. So it's very hard actually to follow after such a nice presentation from Alan. I'll try to do my best to give you some flavor about the Copernicus Atmosphere Monitoring Service. Some of you in the room are already aware of the service, aware of the precursor projects that have been delivering information so far, and some of you are not. So I will try to explain why we are here, what we deliver, and what kind of benefit there is for users, intermediate users, to build upon the service that we deliver. So first, trying to answer the why. So as many of you know, one of the main ways through which human activities in general is affecting the Earth system is via the composition of the atmosphere. So I could spend an hour to explain you in terms of quantities, etc., why this is a pivotal element into the Earth system. And indeed, all these activities equate to emissions that are released in the atmosphere. And these emissions build up levels of some constituents, greenhouse gases. So you've heard obviously of carbon dioxide, methane, etc., but also other pollutants like aerosol particles in the air, ozone, nitrogen oxide, etc., and etc. So these elements, you've heard about them because they are pivotal in a number of environmental issues that the world is facing. Not only the developing world, not only the developed world, all the world. We are speaking about air quality, climate change, the ozone layer and the ozone hole. And all these big environmental chapters have impacts on, back on us living on Earth. They have impact on health, and they have impact also on the well-being. So there is a loop actually, and the pivotal element in this loop is the composition of the atmosphere. And having a Copernicus service on the composition of the atmosphere is very important for that reason. This statement that we can manage only what we can monitor does apply very much in this context. So just to give you a feel on how important this is, just using the example of air quality, this is a figure which I use very often in presentation about the atmosphere monitoring service and air quality, why it is so important. Maybe you didn't know that every human in developed countries eat every day on average 1.5 kilograms of food, and it's just legitimate that people are very concerned about the quality of food, organic food, etc. Conversely, we drink about 2 kilograms of water on a daily basis. And would you guess how much air we process in a day? It's 14 kilograms. It's massive. So it's no wonder why air quality is really essential for life, and there are lots of health impacts about air quality. Just to focus on Europe, I have taken figures from the European Environment Agencies. They are providing regularly updates on the quality of air in Europe based on national observations. And this table, I will not go into detail, shows that across Europe, for many pollutants, particulate matter, ozone, nitrogen oxide, etc., you have an excess of 90% of the European population which is suffering from levels of pollutants which are above the recommendations of the World Health Organization. So the situation has been improving over the decades. The situation is relatively good in Sweden compared to other places in Europe, but still there is a very big problem for the European Union to be faced. And actually, when the Copernicus program was designed, there was a cost-benefit analysis, a study of where more information, more reliable information could bring a benefit to Europe, and air quality was singled out as a second topic where investing in Copernicus, investing in better quality information could get the highest return on investment. So really it's no wonder that among the panel of 6 services that Mauro presented earlier, there is a service about atmosphere and especially about the composition of atmosphere. So you can already visit the website of CAMS, so Copernicus Atmosphere Monitoring Service. This website has been redesigned in last July, as we've had for the last almost decade precursor projects that have brought us to the status that we are. So even if CAMS has a delegation agreement between the Commission and ECMWF was only signed in last November, we were already on board the train, which is going full speed, and we can deliver operational services. So, yes, we have a significant heritage. This heritage builds for me on 4 pillars. The first pillar is a long-term strategy, and Mauro mentioned already this Paveno Manifesto, where a group of people met in '98, not so long after Kyoto, and designed a short but very good document about the strategy, the vision that countries and Europe need not only agree on principles like Kyoto, but also take measures to be in a possibility to monitor progress. So this document, which was drafted in '98, is still very valid. What came on board a bit later, so the environmental drive and the SDGs, even if at that time it was the Millennium Goals, are already embedded in the long-term strategy for Copernicus. An element that developed along the years is the assessment of what could be the potential of Copernicus also in terms of socio-economic development. And there have been a number of cost-benefit analysis, socio-economic analysis, to assess whether it was worthwhile launching this 4.3 billion euro investment for Europe to bring also a benefit in terms of job creation and growth. And with time passing and with the crisis, this second very important strategic dimension of Copernicus has been very important. For specific services like the atmosphere service, we have been interacting for a decade almost with experts, considering the available Earth observations, the available in situ observation, the modeling capability. They gave advice on what would be valuable candidates to populate the portfolio of an atmospheric service. And the last pillar is the interaction with users. For the last decade, we have been showing prototype products, discussing with users in different categories. I have a few slides on that, to get to the position that we are today. So how does the system work? Again, I could speak for quite long. I will just cut it short and show you basically the route that information and observation takes to be digested and deliver in the end products that are of policy quality. That is the best that we can do with the current capabilities. So in the case of the atmosphere service, we build upon the infrastructure of weather forecasting. So I work for the European Center for Medium-Range Weather Forecast, which is an entity which is supported by the national weather services like SMHI in Sweden, and that focused in the past on medium-range weather forecast. And for that purpose, that is forecast from 5 to 10 days, and for that purpose, it needed to develop a very big infrastructure to gather observations, to develop models, and to ship information to stakeholders and users. And so to develop the atmosphere service, and we'll see later also the climate service, we have built on this infrastructure, and today to deliver the product range of CAMS. We use about 70 single instruments that are taken into account in our modeling system. This modeling system delivers products at the global scale, and I will show you a few examples of these. These global products, they feed into other systems that allow to zoom, especially over the European domain, and I will show examples of that. And we can further add some observations to build in the end the elements that you what you see. Where is it? Yes, that you see there, which are maps that can be used for assessing exposure, for instance, of population or crops to a number of air pollutants. So the way the system, the Atmosphere Monitoring Service is structured is an acquisition of observations. I mentioned here especially in situ observations, because besides the relying on the country-based provision of in situ observations, in the case of the Atmosphere Service, we rely also on very large international research in situ networks working to acquire in situ or surface-based observations. The second block of activity is about delivering products at the global scale. We have products at the regional scale covering Europe at high resolution, and we have supplementary services which are built upon the core raw production from these two. Then we have transverse activities that will validate all these products. A key dimension of Copernicus is not only to deliver products, but also to deliver the best we can do in terms of validation, so that users can see whether the products are adequate for their purpose. Emissions, which is a crucial product in itself and crucial for the service. And last, transverse activities in the field of communication, training, and user interactions. So the way this has been implemented, as you saw maybe on our small graphics, is that some activities are done directly at ECMWF. These are two of the activities for the global system, but all the rest is being, or has been for some, tendered to external providers. So this year we have opened about 15 tenders, and we are about to launch 6 more in the coming few weeks to acquire the best we can get in Europe for the different elements. So that's in terms of producing information, that's in terms of delivering certain specific products for certain specific users, and in the end the CAMS is a group of providers coordinated by ECMWF delivering these services. What we aim at is that this is not really seen by the users. The user sees a portfolio which is homogeneous and which they can take benefit upon. So what do we have in our portfolio? Very briefly, services in the field of air quality and atmospheric composition, air quality, forecasts, assessment, as the maps I've been showing. Pollen forecast is an area where we have not an operational product, but an experimental product. So in season of pollens, we deliver such forecast. And also something important I will show as an example are the transport of pollutants. So you can think of desert dust that come over Europe, even over Sweden, and contribute to particulate matter levels, can be large wildfires, etc. Climate forcing is an area also where we work a lot, as we have all the different components of composition, greenhouse gases, aerosol, reactive gases. We can compute the forcings on the climate. Ozone layer on UV, where we are with the recovery of the ozone layer, and what are the consequences for UV radiation at the surface. Solar radiation is one of our big area, and I have a slide to show what we do in this field. And the last important field where we have products in the portfolio are emissions at the surface, in particular emissions in real time from fires, but also very important surface fluxes of CO2, methane, or N2O, so the key greenhouse gases. So the way to access all these products is through the website. You have here a catalog, and when you go to this catalog, you have basically a menu. You can search also by keywords to get to what are the products that are relevant for your selection. We have around 200 different products, so that's the best way we found to, for the users to navigate through that. And once you've selected a certain product, you have a quick look, and you have access to plots, data, verification results, or you can also contact our support to, if you have specific questions. So the result of this long pre-operational precursor project is that today we have several thousands of users. It's actually more than 3,000. I can't say if we have crossed the 4,000 bar yet. But as an example, I wanted to show you what is the distribution of the users in terms of countries, single countries, for one of our products, which is the chemical reanalysis, which is very much used worldwide. You see that the single country using most our data is China. So it's about 250 individual users from China downloading this free and open data. So it's a very, very good sign. In the world competition, if China is looking at our products so intensely, it really means that we are on top of the world in terms of the quality, the completeness of the data. We see also a reasonably good uptake in Europe, even if there is some progress to make. And actually, in the recent months, we've seen a quite significant increase, especially in the users of the time-critical products. In the past, in the precursor projects, we could not guarantee certain levels of time criticality in particular. We're now moving to the operational service. The forecast that we can deliver as reliable as the weather forecast. So you can start developing lots of applications, publishing papers, using smartphone. There will be some data every day, whatever happens, and we see this very nice doubling. I think within a year we will double the number of time-critical users that will complain if the data is not here in the night when it should be available. So I have little time to go into detail on who are our users. The fraction between the commercial users, the administration, policy users, the science users, and the other type of users, like general public or general interest, are very varied depending on the category of the services. For the global product, science users is our main population of users. Commercial is very limited, and if you look at the other end of the spectrum, for solar radiation services, the majority of users are in the private sector, and science is much more limited. So as part of our activities, we frequently meet with users. I've put pictures of the two last meetings. In May we were in Rome, in March we were in Vienna. And what the users say is really important to us. So for years we've been listening to users, gathering their main points. The main point that came forward in the past was the products and services need to be sustainable. They were saying, okay, your project is very nice, your products is very nice, but my company doesn't want to invest in these products if you can't say in 2 years they will be still up and running. So this has been, with the regulation that Mauro indicated, this has been granted at least for until the end of 2020. The other elements that the user put forward is that the raison d'être of the products is quality. If you're not delivering quality, you're not delivering validation. Well, there are other products on the internet, and Copernicus will not make a difference. So quality is very important. Full, free, and open data policy, also with a very strong request from the user, and this has been granted, so that's very important. And other elements that user mentioned, very often it's related to easiness of data discovery, access, visualization, manipulation. So we are into this cloud computing, allowing to compute near where the data resides. the need for support and training, and very importantly, we gather from the user feedback and requirements. So these requirements and feedback, they really drive short-term changes in the services. Medium-term developments, sometimes user requests for things that cannot be developed within a matter of weeks or months. And also that goes all the way to helping design the next generation of the space infrastructure. So in this consultation with user, working with the commission, working with other providers, we aim at driving at a different time scale the program in the right way. So now the rest of my presentation is on some highlights of what we deliver in terms of products. Yeah, it should be good. So the first thing is high quality, I mentioned that. So we were very glad actually that the products of the precursor of CAMS were taken up very much in the last IPCC assessment. And for most of these elements, which are the forcings to climate, the precursors of CAMS have provided information which has been used in the IPCC report. Another sign of the good quality of our products is that the US community, the Bulletin of American Meteorological Society, has been doing for some years a document which is a state of the climate, where they collate all the best information possible on the state of climate. And regarding atmospheric composition, CAMS is the major provider for this report. C3S has a reanalysis, which is also one of the major components of this report. So that's two European Copernicus elements that feed into this very highly recognized source of information about the recent climate. Something very important that we are doing, and we are really pioneering in this field, is using Earth observation data to work on greenhouse gases. That's so working with a number of providers in Europe. We have been using satellite instruments that are either European, like YASI, Japanese, TENSO, and we had NBSAT, which also was providing lots of interesting information, and we are now working on an American mission called CO2. So with that, we are able to provide real-time, or just with a few days of delay, information on the key greenhouse gases. And this is an example of our CO2 product, and this is a validation against a completely independent observation. So what we assess with CAMS is in red, as you see, and what the observation see from the ground is in black. So you see that now we have a really high quality of this product, which is CO2, and this has a number of applications. If you want to assess what is the footprint of a certain event, if you want to process satellite data, and you need to have fields of CO2 in the atmosphere for your radiative transfer, that's one of the products of CAMS that has gained lots of momentum in the last few years. Other products are also interesting for developing jobs, and there certainly the key sector is solar radiation. What CAMS has brought to this community is provision of very accurate aerosol information. As you know, particularly in the atmosphere, modify radiation at the surface, and you have lots of companies these days that are working on assessing the potential benefit of installing certain solar plants or equipment. And in order to do that, you have two possibilities. One possibility is to put a sensor and wait for a few years, and then you know you can do your cost-benefit analysis. It's very good, it's very accurate, but it takes time to do that. The other way is to use models to try assess using satellite Earth observation what will be the yield of a certain solar installation. But up to now, this community was working with climatological information about aerosol. So what MAC has brought is aerosol information with time variations, and this allows, compared to ground truth on a case here in Spain, showing that the whole spectrum of the solar radiation can be reproduced with MAC, meaning that now the cost-benefit analysis that this company and other companies now can do is much better, so that there is less risk to be wrong in analyzing whether solar equipment will be useful or not. Air quality is an area where CAMS is very active, and in that we are involved in where we support the decision-making process. So this is a case in the last spring with a very strong plume of dust that affected up to the north of France. So you see there the plume of dust. So this information is taking into account satellite observations. So aerosol optical depth is modified by the observations of satellite. This information is driven into the regional air quality systems that operate at 10-kilometer resolution. And in the end, we get an assessment for the decision maker that on that day, on 2 days in Paris, it was very likely to have exceedances of the threshold for large particles, PM10, because of this dust event. So the practical implication was that there was no real interest in making a car, for instance, banning car traffic or banning industry in that day, because most of this event was purely driven from this dust. So that's very useful, or when there are cases of fires, that's very useful to be able to assess whether local measures or measures at the level of a country will make a difference. Sometimes, and very often it is the case, or cases where it will not make little difference. Another example, I have no time to go through that, was the Barbadunga volcanic eruption that caused a high level of PM on the north coastline of France, Benelux, and also UK. And actually, using data from the OMI sensor, bringing in this the SO2 that was coming from the volcano, we could reproduce very nicely the very high level of sulfate, in that case, that we are monitored, here with an example in the Netherlands, or that was seen also in a number of sites across Europe. So in that case, it's directly the space observation that can feed into the system to tell what will be the particle in the air, and so help the decision maker to decide whether something has to be done or nothing has to be done locally. I could go on and on. I will skip for the sake of time. Fires is an area where we have very good information. Something I wanted to comment is on the air quality products that we deliver for Europe. We deliver daily forecast up to 96 hours. These forecasts are done with an ensemble of models, so that's not just one model. That's 7 systems that run with similar conditions. One of these systems, by the way, is run by SMHI. And with this system, we are able to deliver this information in terms of not only of a single value, will a certain threshold be exceeded, we can provide, and we do provide, a range of uncertainty so that the users can decide. And we have a very large crowd of users now that need our information on a daily basis. We have a handful of smartphone applications. Google has contacted us to get access to this data, a number of newspapers, and now a large number of companies developing wearable technology to have air quality information embedded. Last example, because it's a nice one, it's a site in Ushuaia that makes soundings, ozone soundings, trying to measure into the ozone hole. These ozone sondes are very costly to do, and what they want to do when they launch a sonde is they want to make sure that they launch a sonde when the ozone hole is above their head. And to do that, they use, for the 3rd year in sequence, our forecast of the ozone layer in order to launch the sondes exactly at the right time to pick up when the ozone hole is just above. And to do that, I wanted to show that, and to come back to Earth observation, this is a comparison between our product of the ozone layer compared to ozone sondes, which are of good quality. Basically, where you see no color is that our product is very good, is very similar to the sonde. And where there are colors, there are discrepancies, either too high or too low profiles. What you see clearly from there, so it's one side in the northern high latitude, one side in the tropics, and one side in the southern high latitude. You see a period where the output of the system is much worse in all cases. And this is a period where we didn't have space observation of limb sounding. And so we see clearly that if we don't have such sounders, we have a drop in the quality of the product. And that's an example I use to show that the requirements of users are really essential to drive the evolution of the Copernicus space infrastructure. If there are enough users that want to have an accurate presentation of the ozone profile, we need an instrument of that kind, or an instrument that will allow to fill this gap. Last slide for conclusion, about the opportunities that CAMS provide. So CAMS is now operational. It's one of the services that are delivering today because it has this long prequel of research project. In order to access the product, please go to our website to become a user. It's pretty simple. You can ask questions, say what you think, and also be in the loop of being invited to user events or training sessions. We have opened in last July a Twitter account for Copernicus services at ECMWF, so this is an example. Currently we've been tweeting quite a bit about fire in Indonesia and their impact recently. The other way CAMS provide opportunities is that, as I said, we are tendering lots of the service provision activities. And with CAMS alone, we have 6 ITTs that are to go within a month. And the website to go there is on ECMWF website, and you can become a provider. I know Swedish entities and companies have been part of bids or have been leading bids in the past few months. I want to advertise also, especially towards SMEs, that we are launching next year in the spring a set of competitive calls on use cases. What we want to do is to try stimulate innovative ideas that have strong, in particular, commercial potential. The idea is to help with the initial investment to get the data and develop fully the idea to a scale that then the business case can be made properly. So that's something where we expect there will be lots of attention and attraction for small industry in particular. And the last way there are opportunity for CAMS is that with these, the funding from Copernicus, you are very welcome to apply for Copernicus position either at ECMWF or at one of the CAMS providers. Thank you very much.
Thank you very much, Vincent-Henri. Any questions? A short one. We got one from SMHI.
Thank you, Vincent. Stefan Nilsson from SMHI. I have a very specific question for you regarding the in situ network in Europe and also elsewhere in the world. You have talked very much about using satellite data here, but how do you think about the in situ network and the supporting for that?
Yes, so when moving from the research phase to the operation phase, we detected that there was a specific issue for the atmosphere service, that a number of key observations are not done in the context of national regulatory context, like air quality, but in the context of large global observing programs, which are research in nature. So that's why we negotiated with the European Commission to have a specific activity, which is to support with a small bit these networks so that they can prepare their products in a way, or transmit their product in real time in a way that can be used by the service. So that's really complementing the overall picture of Copernicus, because for atmosphere observation, but there are also similarities with the marine service. I don't know if Pierre Bayerel will mention that this afternoon, to support international networks that are research-based and nevertheless have a capability to provide information of sufficient quality and fast enough for the operational service, and that's what we are supporting with Copernicus.
Okay, thank you very much. I think we have to break there. If I may ask Mauro and Alan come forward, you will all get presents. It's very fun. This is a small token of our appreciation that you came here. Thank you, Mauro. Here you got some nice pictures from our northern part of the country. Thank you so much for joining us.
We spoke my Swedish.